You here? Let's give a round of applause for Sönke and Alex and their talk, nixos-compose.
Thank you. Thank you and welcome to the nixos-compose talk. This is Alex David. I'm Sönke Hahn. We both work at Nix, which is this company that provides CI services and hosting for Nix projects. But we don't want to talk about that much. We're going to talk about hosting a little bit later, but we mainly want to talk to you about nixos-compose, which is this open source tool that we wrote at Nix. But before we dive into that, I want to talk to you about Docker Compose. Docker Compose is very popular to set up these configurations where you can spin up Docker containers locally on your development machines based on Docker images. And it's very popular, especially if you have a project that also uses Docker to deploy to production. And there's a bunch of use cases for this. Of course, you can use it to debug your system, right? Like you can spin up like 3 containers, for example, a front end that talks to some backends and then see how they interact. You can also use that to spin up a container and then, for example, run a test suite against that, right? And overall, this approach, I think, is really, really elegant and nice. And I've used Docker Compose in past projects, and I always enjoyed it. And it's really nice because it brings production and development very close together, right? And that's mainly cool for 2 reasons. One is you save some effort into declaring these things. For example, if you have a database configuration, you only need to write that down once and then use it in production and in your local development environment. But it's also really nice because your development environment is so close to production and you can see how it behaves much earlier, right? Like it helps you see, do these services actually interact with each other in the right way? Or you could, work on one of these services and run them locally and then run them against a backend that runs in a Docker container. And that's really great and awesome, I think. Next slide. The problem with that, of course, is that I don't really like Docker. I think containers are really neat. But Docker is not really nice, and I really, really don't like Kubernetes. And what we do at Nix, and what maybe also a lot of people here do at work, is that we specify our software with Nix configurations, like with the software with Nix derivations, and then the machine configurations as NixOS configurations. And we use that to deploy to production. But what that now means is that I feel there's this Docker Compose-shaped hole in the Nix ecosystem, right? Like there's nothing that really makes it easy to spin up machines locally to fill the role that Docker Compose fills when you use Docker for production deployments. And that is the hole that nixos-compose is trying to fill, right? Like so here you can see an example of a flake file. And in flake files, you can declare these NixOS configurations that are configurations for your whole machines. And you would usually do that to deploy to production, right? And what nixos-compose now makes really easy and convenient is to spin up VMs locally in your development environment for all the machines that you declare in a flake file like this. And of course, that comes with the same advantages that Docker Compose has, right? Like that you bring production and development very close together. This is the outline of the talk. The motivation section was what you just heard, so we are now after that. The rest of the talk we're going to spend on demoing nixos-compose. So there's going to be a lot of demoing in between for all these points. We're going to show you how to start and stop VMs. We're going to show you how to enter VMs with SSH. We're going to show you a little bit how to inspect logs in the VMs that you bring up. And we're going to show you how to network between VMs and how to do networking between your host, which is your development machine, and VMs. And then we're also going to talk a little bit about hosting in production at the end. Right. So this is like the most primitive feature of nixos-compose, which is startup VMs. And as you might have guessed, this is heavily inspired by the Docker Compose CLI. So what you do is you just cd into a directory that has a flake file that has Nix configurations declared, and then you say, yeah, you can see that here. So this is a demo repository that has 3 Nix configurations declared: AI, DB, and web. And then in here you can run nixos-compose status, and then you can see that none of them are running, right? Because we haven't done anything yet. And then we can run nixos-compose up, and the -v is the verbosity flag, which means that we will see some log output. And nixos-compose will now start building your Nixos configurations with Nix, right, in parallel. And it will show you some log output from building all the different machines. And then afterwards, it will start booting them up in a QEMU VM. That also happens in parallel. Now you can see that all 3 are booting, and we have to wait for that to finish. So now we're still waiting for the last machine to boot up. And this is the output that you can see here is systemd spinning up all the units that are defined in your nixos config, right? And now you can see that nixos-compose status tells you, yeah, these are all running now. The next command that we want to show you is you want to interact with these machines. And the most basic thing to do is to SSH into them. And you can do that by just saying nixos-compose SSH, and then you give it a VM name, and that just works. What nixos-compose does under the hood is it injects some configuration into your Nixos configuration to make this work, right? So what it does is it adds a user that is called VM user. It does enable SSHD. It does inject an authorized key, like it just generates a new SSH key and injects that into the authorized keys for that user. And it port forwards the SSH port from the QEMU VM so that you can talk to it. And another feature is also that or something noteworthy is that the VM user can gain root access, which is really useful for development environments because you want to fully control these machines and do whatever you want, right? That's that. What you very often want to do with nixos-compose is look at logs, right? And Docker Compose has this specific log command that lets you view the output of processes that are running in your containers. Nixos-compose doesn't have a command like that, and I also don't think it needs to, because you have SSH, and you also, different than like in Docker containers, in NixOS machines and these VMs, you have systemd running, right? And there is journald running, and your processes usually talk to the journal to log. So what you can do is manually just SSH into the machine and look at the logs like that. But what you can also do, which is a little bit closer to how Docker Compose log works, is you can say nixos-compose SSH web and then give it a command, right? And here the -u flag just says, I want to see the logs of the Nginx unit or the API unit. Yeah. And of course, some processes also log into log files, but you can also with SSH just look at log files. You can just cat a file or whatever. The next thing that nixos-compose does, which is really important for being able to simulate these setups of multiple machines, is networking between these VMs, right? So what nixos-compose does, as soon as you spin up your first VM, is it spins up this virtual network switch, which is going to be another process that is going to run on your host machine, and that is managed by nixos-compose. And it connects all the machines to that switch. And it also adds entries into the /etc/hosts file on all the VMs so that they can talk to each other not by the IP addresses that nixos-compose assigns to them, but by the names that you give them in your Nixos config. So here you can see that we can just SSH into the web VM, the VM that is called web, and then there we can just curl AI, because one of our other VMs is called AI, and that nixos-compose will just make that work, right? And the AI machine is running an LLM, and that gives you, if you just curl it, it gives you that. The next example is pinging the database. You can see that, and then this is the PostgreSQL port that it's running on, and Alex just connected to that port, and that works. And yeah, these are the three entries that you get in all of the VMs to be able to have communication between the VMs. And one thing that is really cool about this, I think, is that in your application code, you don't have to tinker around with passing in the domain that you want to use for talking to other machines, because they just have names, right? They just have the names that you give them in your Flake file. So here you can see that the JavaScript code just says like, well, talk to HTTP ://AI/API, whatever. And that just works, which I think is kind of nice. The next thing is networking from your host, which is your development machine, to the VMs, which means nixos-compose has this command that is called tab, which sets up a virtual network interface on your host. It does require sudo, so you have to put in your password. It also allows you to not use sudo if you don't do that. You can say --dry run, and then it tells you what you have to run manually if you prefer that. But you have to run it with administrative privileges because it creates this interface on your host. And it will also set up your networking so that all the traffic that goes to the subnet, like 10.0.0, goes to that interface. And as you can see, all the IP addresses of the VMs are in that subnet. So then it sets it up so that you can talk to the VMs through that subnet. You have to use the IP addresses. So on your host, it doesn't work to just say, curl AI. That we could support that in some way at some point, but currently that doesn't work. But yeah, then you can talk from your development machine to the VMs. nixos-compose also provides this command IP, where you can just say nixos-compose IP web, for example, and then it just spits out the IP of that VM to standard out, which might be really nice for some scripting or something like that. And this is really useful for a lot of use cases. Like without this wouldn't be as useful. For example, you want to be able to run, you want to be able to PSQL into the DB VM, right? Like just to look at some tables, or maybe to just modify some data in there. Or you might want to run a graphical client to browse your database or whatever. And a lot of projects, of course, are also websites. And very crucially, this feature is needed to look at a web application that your system provides, right? So here, Alex has just opened a browser and then pointed it at 10.0.0.19, which is the IP of the web VM. And our demo repo has this very nice, modern-looking interface that allows you to ask the system to generate facts about a topic that you give it, right? So, and then now this web VM will ask the AI VM on Alex's laptop for fun facts about NixCon 2025. I don't know, the first time it didn't work, I don't know. Yeah, and we have to wait for it to process. And then it says, certainly, here are some interesting facts about NixCon 2025. NixCon 2025 is a global conference for the Internet of Things industry that brings together professionals, researchers, vendors, investors, and business executives from various sectors. It will be held in Seoul, South Korea, so I think you're in the wrong place, I guess. But yeah, so that's what it does. And then the VM, the setup allows you to save these queries once it's done generating. Yeah, then you can save it, and as you can imagine, this now talks to the database VM and saves this query, and then we have a listing of all the saved queries here, which are saved in the database. So that's that. Right. Of course, you don't want to just bring up VMs, right? Like you do all this thing because you have some software that you want to deploy to production. And there's lots of options for doing that, right? Like you can deploy to all kinds of cloud providers, and there's different tools for that. The nice thing about this kind of setup with nixos-compose and the Flake files is that you already have the Nixos configurations, right? Like that's already kind of very close together. And we are hosting this demo on garnix.io, which is our hosting service that makes it also fairly easy to just say like, oh, here are a bunch of Nixos configurations, and then you push to GitHub, and then it just deploys your machines. It does require some manual configuration. Like if you remember, we had this TypeScript snippet that just talked to the AI host. And of course, in production, that doesn't work just out of the box without you doing anything. And that depends a lot on which cloud provider you're using, or like how you're deploying this and how these machines are accessible in production. What we came up with for this demo that is hosted on Garnix is a system where it establishes WireGuard tunnels between the machines, and then also injects these entries into the etc hosts file so that the code actually doesn't have to change. So this code snippet that you saw is also running in production, just like that. Right, and it's hosted here on nixos-compose-demo.garnix.io.garnix.me, which is the default URL that you get when you deploy something like this. And please feel free to go there and generate facts about other topics that you might be interested in. If it goes down, then it goes down, and I guess that's a success. We also put up this demo repo for you to look at. I think this could be both useful for looking at, for toying around with nixos-compose, right? Because it has like 3 machines that actually talk to each other and that work and that are set up to work like this. It might also be interesting to see how the WireGuard setup works in there. This setup is like a little bit something that we've been thinking about and talking about. So if you're interested in that, you should also definitely come talk to us. That would be interesting. And that's it. Thanks a lot for your time. And also, I want to thank all the organizers of NixCon. It's pretty nice and cool. This is the URL for the nixos-compose tool. There's also a Flake file in there, so if you want to check it out, you can just nix run it if your Flake's enabled, and start trying it out. And please, if you have feedback, also find your way to the issue tracker or write us an email or something like that. Thank you.
Thank you so much for the new facts about NixCon. Any questions? We're going to start right here.
Yeah, thanks for your talk. I have a kind of again, bizarre question. So the main benefit of Docker Compose is that we just spawn processes in like rooted directories with different namespaces and possibly C groups. But with VMs, it seems like we need to bootstrap a VM. It would take, considerably a lot of time.
Right.
So how do you overcome that? And on top of that, I think this is also a pretty related question. So whenever you run, let's say, NixOS, rebuild boot, or switch, doesn't matter, on your host machine, you have sort of cache that you can use every single time, and you wouldn't rebuild everything. Do you have a solution for that in the VM, or do you use a clean state every single time?
Right. Yeah, that's a good question. So first of all, the way that we use Nix to deploy our software is fundamentally different than Docker deployments, right? Like we don't think of this as like, oh, there's these processes that run in these containers and then they talk to each other. No, it's like, no, this is a machine that has a system D configuration, and it might run like all kinds of things in there. And we also do run multiple services on one machine, which I think in the Docker world is like something that you would rather avoid, right? So to be able to test what we're doing locally in development, you need something like VMs, right? Of course, this comes with drawbacks, right? Like this is not as fast as spinning up a process in a Linux namespace, right? And I think there's another tool that. Well, I actually don't know exactly how the tool works, but like I think there would be some value in a tool that would allow you to spin up stuff from Nix in a Docker container really fast, or in a container really fast. But you would also lose some things, right? Like you would also lose, for example, testing your firewall configuration, which you might really want to test, right? You don't want to fat finger that. But yeah, it has drawbacks, has downsides. Sorry, and the second question was, right, whether we start from a clean slate or not. So we piggyback off of the QEMU images that you can build for Nixos configurations out of the box from Nix packages. And the default setting there is that you mount the host store into the VM. And then it's all already there, right? Yeah. But I think still containers would be faster, yeah.
Next question, let's go over there, then here, and then up in front.
Yeah, this seems super cool.
Thanks.
Well done. I had a question, like you also tangentially touched it now, that it's supposed to emulate the machines that you're also running it on. So is there any way to make more complicated network topologies? Or, for instance, attaching it creating an OVS bridge myself and then attaching to that?
We haven't thought about that much. Currently, how it works is that nixos-compose just lets every machine talk to all the other machines, right? Just to make it as convenient as possible, I guess. But of course, that leaves out some things that you might want to test if you have more complex topologies. But yeah, I don't know. Sorry, that's a bit of a non-answer, but.
Check. I see that you are using ThinkPads, which are really nice. I use MacBooks. Does it work on MacBooks as well?
No, it does not. When we started working on this, well, first of all, we wrote this for ourselves first, right? Like that's how it started. We had a very convoluted ad hoc collection of shell scripts that really weren't fun to work with. And we are all using Linux, and that's what it works on. And we made the decision that we wouldn't tackle that because we're out of our wheelhouse there a bit, right? I don't know right now, for example, the tool shells out to IP to set up the networking, and that's just not available on Macs. I think that would be easy to fix, but does QEMU run on Macs? Yeah, I think so. But yeah, it does. Okay, yeah. Then I think it wouldn't be too hard to make it work. Sorry. Right. Yeah.
Okay, the next question up in front.
Hey, so this is wonderful. I am keen to use it. But you say you're basing it on Docker Compose, and to me, it is just screaming vagrant. And if you're not familiar with the tool, it has the concept of it does the same thing. It provisions VMs according to some spec, and it has this wonderful concept of provisioners, where they allow you to just abstract away the materialization. So instead of heavily pinning it down on QEMU, it's whatever, and then you can do Google Cloud and something like that. Is it feasible to expect this tool to go into the direction where you're not bound to specific virtual machine creation?
I don't think I'm missing that feature, so I'm likely not going to build it. In general, for this question, also your question, we would love contributors to this project. It's open source. If you have a Mac and you want to take a stab at this, please do, right? And if you are really interested in this and would love to work on it, it's written in Haskell. Yeah. Yeah, I didn't say that to scare anyone. Like please come just as information. Yeah. But yeah, like I think I'm personally not going to build features that I'm not missing, and I'm fine with QEMO right now, and that works good for us. Yeah. Yeah.
And then one last question.
Yeah, thanks for the presentation. I think it's a really interesting project. Like the main use case for me to constantly provision and spin up new VMs is kernel development. Do you think, did you have any such use cases in mind, like where you try to directly boot the kernel, where you have to specify more QEMU command line parameters, for example, where you don't want to rebuild your NixOS all the time with an incrementally compiled Linux kernel?
Oh, we haven't thought about this.
I could imagine it's not something that's useful to Garnix IO, but would you still you think it's a direction that contributions could take, or are you?
I think so. Yes, yeah, I think so. I think what we were striving for when we built this is like a really polished experience for the normal, for like the usual use case and our use case. But I could imagine building something like that doesn't interfere with that at all, right? So I think that's very welcome, and also a good example of something that you cannot do in containers, right? But also maybe not a super big use case like number-wise, but yes.
So I'm figuring the first contributor gets to pick in which direction it goes. So maybe you're the first.
Well, then, all of these directions are also not like mutually exclusive, right?
Then thank you again for the great talk, Sönke and Alex. Give them a round of applause.